Hello, maurieos, 2019 Engineering Maths Weekly Quiz 6 Review. Hello, welcome. Well, we've got the builders in next door, so you might hear a bit of hammering and skill sawing and what have you going on during the course of this review, but, well, perhaps it'll bring it to life in terms of what life on the construction site might be like. You sit in your site office and contemplate great engineering feats of construction. The tap of hammers and chisels may well be what you have to contend with. So, this is Weekly Quiz 6. As is the case, as an incentive for students to watch this, there will be a small prize for the first student in the class to identify the location of the auspicious building behind me in the comments below the video. So no one picked up last on Quiz 5's review as to what that picture was, and so this one here, it's open just for the week until the next video is made. So enough of that, let's head over to the big screen and make a start on question 1. Find the equation of the graph. Now, as we can see, this graph here is it's a decay graph. You can see as negative numbers are large, and then as it gets large and positive, the number gets smaller and smaller, and it's actually approaching the x-axis as an asymptote. So from that, we're able to determine that it's an exponential graph, an exponential decay graph, in fact. So what we know is that it's going to have the equation, if I can get the pencil to write here, the felt pen. Oh yeah, there we go. I'll just undo that. All right. So it's going to have the equation y equals a e, or this is the standard form of the equation, e to the negative kx. Like that. So the first thing is you have to identify that it is that exponential decay graph, and we know that its k is going to be negative. Now, this doesn't appear so much on the formula sheet. So this is something that one of those little factoids that it would probably be a good idea to remember going into an exam. Now, what we know is if we look over here, when x equals 0, y equals 3. So let's just have a look at that situation there. So we know that when x equals 0, y equals 3, and I'm going to underline that, or almost bloody obliterate it actually. So when x equals 0, I might undo that, see if I can do that a little bit better. There we go, and we'll just put that down there like that. Okay, so what that tells us is now we can substitute 0 for x into the equation, and 3 for y. So then we can say, well, 3 equals a e. Now, negative k times x. X is 0, so that's going to be e to the power of 0. And, well, what do we know? What do you know? E to the power of 0, anything to the power of 0 equals 1. So straight away there we can say a equals 3. Oh, there you go. It's all done. Well, a's done. Now we just have to find out k. So now we've got, so this sort of tells us that our graph is something like this. Y equals, a is 3, e to the negative k x. All right, so now let's move on from there and we'll have a look at when x equals 4, which is here. When x equals 4, y equals 2. I'm going to try and underline that one as well. Okay. Yeah. Okay. So now we can fill that into there. So when y is 2, so we get 2 equals 3 e to the negative k times, oh, not 2, it's 4, isn't it? Negative 2 times 4. So we'll undo that. Negative k. We can put a little dot sometimes for 4. Alrighty. Okay, now looking at that, we've got 2 there and 3 times this thing here. So we really want to get e on its own because that's what we can deal with. So I'm going to divide both sides by 3. So what I get is 2/3 equals e to the negative 4k. 2/3 equals e to the negative 4k. Now I'm going to take the log of both sides, or the ln of both sides, the natural log of both sides. Okay, and so I've got ln of 2/3 equals negative 4k. Okay, because if we take the log of the e, we just get the exponent, and that is will be indicated on your formula sheet there. So we just take the log of anything e, will come down to that. Now what I'm going to do is I'm going to divide through by negative 4, and that will give me k. And that equals log of 2/3 all over -4. And I've done this at home earlier, I'll prove it in a minute, but that equals 0.1014. Now we'll just get our calculator up here, and let's, oh, where's it gone? There it is. And let's all right, so let's go, where's log 2/3 2/3, close the brackets, log of 2/3 divided by, this might not work, I had a bit of trouble with it, -4 equals, oh, there we go, 0.1013. I've got 0.14. So therefore, the equation is y equals oh, where's that calculator? Oh yeah, y equals 3e to the negative 0.1014 x. (0.14x). Now just got a little bit of room up here. I'm just going to do a check, and I'm going to say just when, okay, y equals 3e to the negative 0.1014 times 4. Okay. So K is positive. So yeah. All right. So let's get our calculator up here now and just check that out, just to make sure. So we've got 3 times e to the power 0.1014 times, oops, and I've got to go back here, put a 0 in there and go back there and make it negative, and then go right to the end there, times 4. So that should be equal to, what should it be equal to? It should be equal to 2. There you go, 1.9997. I'm pretty happy with that. So that equals, what does it equal? It equals 2. And so I'm going to give that 2 ticks because I've checked it. So there you are. That's question 1 all done. Now you'd probably get one. Oh, I'll maybe do this in a slightly different color for the marking. Got to hit it twice. So that may be a mark for that. There, and well, definitely a mark for the answer here. And indicate where very clearly where your answer is. So there we go. That's question 1. All right, moving right along. Now that took me. I don't know how long has that taken me. Oh, it should have the time, elapsed time there on the video thing, but it doesn't seem to. Okay, oh well, never mind. Alright, so now let's have a look at question 2, which is a similar type of question, except when we look at this one, we can see that it's, well, it's got a vertical asymptote rather than a horizontal asymptote like in the first one. So that tells us that this is not an exponential graph, but a log graph, because it's, yes, it's a logarithmic graph, because it's got a vertical asymptote. The horizontal asymptotes are the exponential, and the vertical ones are log. So this again is a little fact that we need to remember, and we need to remember the standard form of this here. It's not that difficult. Oh, we don't want to do this one in green, do we? No, we want to do it in red. So, so the standard form of the log graph for this type of question here is y equals a natural log b times x. I've got it as a little b, but it could be a capital B. It also can have a plus c over here as well, that'll translate it up and down, or up and down the line, but I don't think that's necessary in this instance, and we probably don't need to worry about that. All right, now straight away then we can see right down here we have the x, well, the x-intercept here at 0.5, and we know there that we've got to do these slightly differently, because the log is sort of the inverse of the exponential, so we've got to do this one. So this is when y equals 0. Okay, when y equals 0. So we know that x equals 0.5. Now, when we look at this equation here, y equals a ln x bx, you can see that the a is what we call a constant term. So it doesn't matter what that is. It could be 100. The only way that it can, y can be 0 is if ln bx equals 0. It doesn't matter, well, if a is 0, it will be, but if a is 6,327, or if a is 47, not going to make one jot of difference. because it's this little bit here that's going to do the. So what we can say there is this sort of implies that 0 equals ln b times x, which is 0.5, because that's the only way it can be 0 is if that's 0. Okay, so and we know that that's going to equal 0 equals ln oh no, we don't need to. I was going to write that. That's unnecessary. I'll just drop that back a little bit. Okay, so now if we take the exponential of each side, remember, because the exponential undoes the log and the log undoes the exponential, so then we can say, right, e to the power of 0 equals 0.5 b, and as in what happened, well, what happened, e to the power of 0 is 1. E to the power of 0 equals 1. Anything to the power of 0 equals 1. So that means we get 1 equals 0.5b. And therefore, if 1 equals 0.5b, which is half of b, 2 must be equal to b. So, therefore, so we have y now equals a. We don't know what a is, but we do know what b is. A ln 2x. Y equals a ln 2x. That's our thing. So now we can have a look at when x equals 2. When x equals 2, y equals 5. Okay, because we've got that point on the graph. We've been given that point on the graph. There it is there. Okay, so we can start filling in. So y is 5. And that equals a ln 2 times x is 2 times 2, 4. Log 4. Now ln 4, that's just a number. We can go on to our calculator and work that out. So therefore we can say that a equals 5 over ln 4. And that equals 3.6067. So let's get our calculator and we'll just have a look at that. All clear, and so we'll go 5 divided by log of 4. There we go, 3.6067. All right, therefore the equation is, of that graph, y equals 3.6067 ln two x. And now we've got a bit of room over here to do a little well, I'll just do my little check thing up here. I'll do it in a different color just because I can, actually. Oh, what's good? I'll go with the green. So we'll just put the little check up here. And so let's just go on our calculator. Y equals 3.6067, because I'm just going here. Ln 2x, which is 2 times 2 is 4. Okay, so that'll go there like that. All right, and let's just see what we get on the calculator. Here we go. Okay, so we go 3.6067 times ln bracket 4. 2 times 2 is 4 equals 4.99994 equals 5. Yep, I'm happy with that. Oops, well, I'm not. Equals 5. 2 ticks. 2 ticks of approval. Even went off the page. Look at that. So there you go. So there's our answer there. Probably get 1 mark in here. Various half marks will be available as well. 1 mark in there. So do the check. Show that you've done the check. I think that although there's possibly no marks for it as such, you know, having done the check, it's good to put those in. Do clearly show where your answer is. Clearly show that, and yeah, that's all good. Oh, and spell correctly and write a little more neatly than I do. Right, so let's move on to question 3. Convert 75 degrees to radians. Now, right, let's get our red pen. Okay, so what we do here is on your formula sheets, you've got a little thing that says pi radians equals 180 degrees. Right? Pi, 1 degree must equal pi over 180. Radians. Pi radians equals 180. 1 degree must equal pi divided by 180. So we divide, I'm just going to put up here, divide by 180. Okay. So you've got to keep your wits about you. You can see there, I knew the answer. I actually got it written down here beside me. And I still managed to copy it down wrong. But when I went to work it out, I thought, whoa, that number's going to be way too big. That can't be right. So now 75 degrees must equal 1 degree, pi by 180, times 75 degrees. Okay? And, well, that equals 1.309 radians. Don't panic, we'll do it on the calculator. That's our answer there. Or you can put 3dp if you want. Go on then. Alrighty. 3dp. So let's get our... So this, remember, this little bit here is in the in your formula sheet. So, well, you know it's there somewhere. So let's see what we got to do. So we go shift shift pi. All clear first, and shift pi divided by 180 times 75 equals 1.309. 3dp. Yeah, 1.309. Now, part A, let's see if I can get this. So we just start from the same place. Pi radians equals 180 degrees. Pi radians equals 180 degrees. 1 radian therefore must equal, and that's what I see, I got it around the wrong way, 180 degrees, 1 radian, 180 divided by pi degrees, that'll be. Alright. So 11 pi by 6 radians will equal 180 over pi see here, I'll just go back up to here, I multiplied by 75 both sides. It's just rearranging the formula. And here I divided by pi. Divided by pi. That give me that there. And now what I'm going to do here is multiply by 11 pi by 6 both sides. times 11 pi by 6. Now you can see there that the pi's cross out. Oh, I'll just do that in a slightly magenta. I haven't used magenta. So you can see there that the pi's cross out, right? 6 goes into 180 30 times. Okay, and then so that equals 30 times 11, oops, which is 330 degrees. (11 pi by 6 is 330 degrees. Okay. So pi's cross out, 30 times 11, 330, 6 goes into pi 30. So, yeah, pretty simple. 1 mark for each of those. Pretty simple, but I still managed, could have very easily mucked it up. But I caught it in time. You've got to keep your wits about you with these things. So, yeah, there we go. Alrighty. So now we're going to turn that layer off, turn that layer on, and we're up to question 4. Question 4. Okay, we've got to select the layer, and we want a red pen. Okay. Using Smooth Draw 4 here with a Wacom tablet. It's a free program, Smooth Draw 4, not too bad. Okay, so we've got this all written down on a piece of paper here. Now on your formula sheet, it's got a the formula, standard formula for a periodic function, which is y equals a sine bx plus c. And we can see here that our formula that we've got here, the formula that we've got here is in that form, and we can see that a is 240, b is, now in this case, t instead of x is 100 pi. And c equals 12. C equals 12. There we go. Right, so amplitude A, and the amplitude equals, that equals A, and that's 240, and that'll be volts. Now the period equals 2 pi over b, and this is on your formula sheet. 2 pi over b, so that equals 2 pi, and b is 100 pi, So the pi's cancel out. What have we, oh, we've been cancelling with magenta maybe? Magenta. Okay, so the pi's cancel out. And the 2 can cancel 1, and that can be 50. So what we get there is it equals 150, 1 over 50, and that's seconds. Okay, now frequency is actually equal to B over 2 pi. It's just the opposite of the inverse of the period actually, and that equals 100 pi over 2 pi. It pays to write this out actually, I think, even though you know there, because it just as a check on the first one, so that's all good. So then here's our this here, so the 100 becomes 50, the 2 becomes 1, and the pi's cross out. Then we go back to the red pen, equals 50, and that's seconds too, is it? Oh, that's 50 per second. $50 per second, that's the number of times it, yeah, it's 50 per second. In this case, that's the frequency. Now the phase shift, just need to go down a little bit on the phase shift here. Now the phase shift, okay, we can, the phase angle equals C, which is 12 radians. Okay, and the phase shift equals C over B. For B, and in this case here it's 12 over 100 pi two goes into that 6, 50, so it's equal to 6 over 50 pi, and we do that on the calculator, and that's equal to plus 0.3 770 radians. And a positive result means it's shifting to the left. We'll just underline that. Oh, not very good at those straight lines. There we go. And we'll just confirm that on the calculator. All right, so we've got 6, all clear, 6 divided by 50 times, oh, I wonder if this will work, pi, I think that might need a bracket. Where did my calculator go? Oh, 6 divided by 50 times pi. Oh, 0.0. Oh, I'm not sure about that. Let's have a look at that. I'll just do that another way. All clear. And that there. No. Oh. 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 Six divided by 50 times pi. Oh, okay. So I've actually got that incorrect there. Okay. Ah, yes. All right, so what we'll do is we'll undo that one. We'll bring our calculator back up, and 6.038 6.0382 radians. Sorry, 0.0382 radians. Oh. 0.0382 radians. Yeah. Okay. Oh, crisis averted. Alrighty. So let's now just drop down and do this one final one here. Between 0 and 90, find the expression without finding theta. So we won't use the calculator, so we can make that disappear. All right, so what we have here is essentially a right angle triangle. Cosine works out a right angle triangle. So let's draw a right angle triangle. Well, what approximates a right angle triangle for me? So that's it there, and that's going to be my right angle there. And I'm going to say cosine theta. I'm going to write theta there. So the cosine of theta, there's the adjacent. Okay, so that'll be, there's the adjacent to theta, root 3. and the hypotenuse is 2. Okay, so therefore this here must be the square root of 2 squared minus the square root of 3 all squared, which equals square root of 4 minus 3, which equals 1. So that's 1. All right, so now we need to just find the sine. So let's go back to red here. Sine of theta equals the opposite, so sine theta equals the opposite, which is 1, over the hypotenuse, which is a half. Adjacent hypotenuse. Opposite hypotenuse. So sine theta is a half. And right, so that would be worth 2 marks there, or maybe a mark for the diagram. Oops. A mark for the diagram and a mark for that there. And moving right up here, well, yeah, it's probably half a mark for each one here. Half, and a half. Yeah, all good. All right. So yes, there we are. Let's just go back to here, and well, that's it. Reviewing of the weekly quiz 6. It's important that you review things, even if you've got it all right. There might be something that you missed or some important fact that you overlooked. So yes, that concludes our review of 6. Don't forget to there's a small prize involved if you're the first person to indicate the location or name of this iconic New Zealand building in the comments below the video. Good luck with that, and we'll see what happens. All good. Cheers. See you. radians. Therefore, 1 degree must equal 180 degrees divided by pi. Oh, not x, pi. By pi radians. Okay, so that's what 1 degree is. So if 1 degree is that, well, 75 degrees must equal 75 times that, surely. Times 180 over pi. Oh, I've got that wrong. I've got that wrong. So I'm just going to go back and tidy that up. I just realized. Oops. Sorry about that.